Hi dear students, now we are going to discuss exercise, that is probability exercise. So first problem, in a cricket match a batsman hits a boundary 6 times. Out of 30 balls he plays. So out of 30 balls 6 times. So 6 balls he hits the boundary. Remaining, it's not a boundary. So it may be 6 or it may be 2 run, it may be 1 run, like that. So now just to consider 6 times he hits the boundary, right? Find the probability that he will hit a boundary in the next ball. So we are going to give the probability form of the chance of hit a boundary. So here our probability is favorable outcomes divided by total outcomes. So total outcome is nothing but total balls he faced. So 30 balls he faced and he hits 6 times a boundary. So 6 balls he hits a boundary. So means number of times on boundary is hit 6. So probability of, that is probability of bracket hit a boundary is equal to 6 divided by 30. 6 divided by 30. So 1 by 5. Right. Next one, not hit boundary in the next ball. So remaining you have 24. How it's possible? The number of times on boundary is not hit. 30 minus 6, 24. So did not hit a boundary. Probability of did not hit a boundary is 24. So 24 divided by 30. So 4 by 5. Using 6 table you can cancel. Our answer is 4 by 5. Right. Next question. 1500 families with 2 children were selected randomly and the following data were recorded. So number of girls in a family 2, 1, 0. Number of family 475, 814, 211 is given. So compute the probability of a family chosen at random having. So here question is number of 2 girls in a family is 475. Number of 1 girl in a family is 814. Number of no girls in a family is 211. You may think that here it may be boy, it may be 1 boy, 1 girl. So this is not a case of this question. Now you are going to consider the number of girls in a family 0, 1, 2. So numbers are given. Now we are going to give the favorable outcome numerator. Total number of outcome is in denominator. Now the total families is 1500. This is total outcome, total number. That is first question, 2 girls, no? So total number of families 1500. So number of family is having 2 girls 475. So 475 divided by 1500. So family having 2 girls, probability of family having 2 girls is 475. So 475 divided by 1500. You can cancel by 25. You can get the answer 19 divided by 60. 19 and 60 are co-prime. No common divisor. You can leave it. Right. Next, number of families having 1 girl. Number of having 1 girl is 814. That's why probability of family having 1 girl equal to 814. 814 divided by 1500. It's 407 divided by 750. Now 407 and 750 are co-prime. So leave it. Next, number of families having no girls. So remaining 211. So 211 divided by 1500 is probability of a family having no girl. Now you need to check sum of all the probability. That is also check whether the sum of this probability is 1. Right. So for that, sum of all probability. First 19 divided by 60. Second 407 by 750. Third 211 divided by 1500. Now 60, 750 and 1500. Using this LCM 1500 because 60, 75 are divisors of 1500. For this question, you may write checking. First one, family having two girls, probability 475 with 1500. Family having one girl, 814 divided with 1500. Family having no girl, 211 instead of 211 divided by 1500. You can write the LCM 1500 easily. You can add the numerator 475, 814, 211. For checking condition, you can write like that, but you are going to write the simplest form of the probability. So simplest form here, the answer 19 divided by 60, 407 by 750, 211 divided by 1500. For that checking condition, you may use the numerator as it is, because anyway you need to find the LCM. Here LCM 1500, so no need to cancel your numerator and the denominator for checking condition alone. Right. So for sum of probability is 1. Right. In a particular section of class 9, 40 students were asked about the month of their birth, and the following graph were prepared for the data so obtained. So here number of students, January 3, February 4, like that, December 4. That in a rectangle height is the number of students is given. Question is, find the probability that a student of the class was born in August. Now August month, 6 students born in August. So from the bar graph we observe the total number of students of class 9 40. Total number of students in a particular class 40. 40. Number of students of class 9 born on August 6. So probability of student born in August is 6 by 40. So 3 by 20, simplest form. So 0.15, you can write like that. Similarly, probability of number of students born on January is 3 by 40. Probability of students born on February 4 by 40. Like that you can write your answer. March 2 by 40, April 2 by 40. But here question is only in August. So probability of October 4 by 40 and 4 by 40 November, and December also 4 by 40. Right. 3 coins are tossed simultaneously 200 times with the following frequency of different outcomes. 3 heads 23, 2 heads 72, 1 head 77, no head 28 is given. If the 3 coins are simultaneously tossed again, compute the probability of 2 heads coming up, only 2 heads. So number of 2 heads is 72, here 200 times tossed, no, so total outcome is 200. So probability of 2 head is 72 divided by 200, so 9. Similarly, probability of no head is 28. So 28 divided by 200. Probability of no head. Probability of one head 77. 77 divided by 250. Then probability of 3 head 23 divided by 200. The same question you are observed that probability of no head. No head means probability of 3 tail. Probability of 3 tail is 28. So 28 divided by 200. Similarly, probability of 2 tail 77. No, so 1 head means remaining tails. So in a 3 coin, 1 head remaining 2 tails. So 77 divided by 200. Similarly, probability of 2 head is probability of 1 tail. So probability of 1 tail 72. 72 divided by 200. So 9 by 5 is 9 by 25, final answer. Similarly, probability of 3 tail, so probability of no head. Sorry, probability of no head. Probability of 3 head. Answer already. Probability of no tail. Probability of 3 head is equal to probability of no tail. So probability of no tail is 23. So 23 divided by 200. So here question is only one question, that is 2 head 72 divided by 200. Instead of that, they may ask such type of question. Probability of no head, probability of one head, probability of three head, probability of no tail, probability of one tail, probability of two tail, and probability of three tail. Right. So you can give your answer. Probability of no head means probability of three tail. Probability of one head means probability of two tail. Probability of two head means probability of one tail. Probability of three head means probability of no head or equal. So you have number, you can take the probability. On organization selected 200 and 2400 families at random and surveyed them to determine a relationship between income level and the number of vehicles in a family. The information gathered is listed in the table below. Monthly income 7,000 less than 7,000 and 7 to 10, 10 to 13, 13 to 16, 16 or more. Vehicles per family. So no vehicle less than 7,000, 10, 7 to 10,000, 0. Not a vehicle. And 1 to like no vehicle, and one vehicle having a more number, two vehicle somewhat, and above 2. So numbers are given. Now suppose a family is chosen. Find the probability that the family chosen is earning rupees 10,000 to 13,000, 10 to 13 per month, and owning exactly two vehicles, 10 to 13, exactly two vehicles, 29 members. So that's why 29 divided by total number of family. Like that we need to give our answer. Similarly, earning of 16 or more, 16 or more is given, and owning exactly one vehicle, 579. So 579 divided by total number of families. So like that you need to give the exact answer. So for first question, probability of earning rupees 10,000 to 13,000 per month and owning two vehicles, 229 divided by 2,400, and the probability of 16,000 or more per month and owning exactly one vehicle, 579 divided by 2,400. Next, earning less than 7,000 per month and does not own any vehicle. Does not means 0. So earning 7,000 per month and does not own any vehicle. So 10 member. So 10 divided by no vehicle, so 0 vehicle. So 10 divided by 2,400. 1 by 240. Probability of earning is 13,000 to 16,000 per month and owning more than 2 vehicles, 25 members. So that's why 25 divided by 2,400. Finally, you can cancel this 1 by 96. Next, fifth, probability of owning not more than one vehicle. What is the meaning of not more than one vehicle? Not more than one vehicle. Check the vehicles per family. No vehicle, that is 10, 1, 2, 1. Having one vehicle, 160, 305, 535, 469, 579. 2, about 2 is given. Not more than 2 vehicle. Not more than 2 vehicle means exactly having no vehicle and one vehicle. So in all monthly income families, don't consider above 2 and above. That is the meaning. So you need to consider probability of a family having one vehicle and no vehicle. That is summation of or addition of 10, 1 to 1, and that is first column. No vehicle, 0. Next, sum of, that is addition of 160, 305, 535, 469 and 579. So sum of the number, addition of 10, 0, 1, 2, 1, no vehicle column, and one vehicle column, 160, 305, 535, 469, 579. So that summation is 2062. So owning not more than one vehicle, not more than one vehicle. So exactly having 0 and 1 vehicle. Okay. So 2062 divided by 2400. So you can cancel by 2. So finally 1031 divided by 1200. This is the final answer. So in all the question, if it's possible, you can write decimal value. Otherwise, leave it. So 1031 divided by 1200, you can leave it. No need to write any cap form or 2 decimal, 3 decimal, 4 decimal form answer. You can leave it the fraction. Right. A teacher analyzes the performance of 2 sections of students in a mathematics test of 100 marks given in the following table. So here marks from 0 to 27 members. So 20 to 30, 10 member, 30 to 40. That table is given, continuous table given. Now 70 and above 8 students and total 90 students. Out of 90 students, 7 students are 0 to 20 marks having, and 20 to 30 marks scored 10 students, 30 to 40 marks scored 10 students, that is the meaning, and 60 to 70 marks scored 15 students, more than 70 and above, that is 80, 85, 90 and 100 are 8 students. Now the question is, find the probability that a student obtained less than 20% in a mathematics test. Less than 20% means less than 20, so strictly 0 to 20, so 7 members, so 7 divided by 90. Find the probability that a student obtained 60 or above, more than 60, so 60 to 70, 15 students, 70 and above 8 students, so sum of, that is addition of 15 and 8 to 23, so 23 divided by 90 is the probability that a student obtained 60 or above. So means probability of 20 percentage 7, 30 percentage 7 plus 10, that is 17 students. Similarly, probability of 50 percentage 50 marks, how many students scored? 40 to 50 scored 20 students, that is the meaning. Now how many students scored more than 50? More than 50 means 50 to 60, 60 to 70 and 70 and above. So 20 plus 15 plus 8. So 35 plus 8, 43. So 43 divided by 90. So how many students scored less than 30? So 0 to 20 and 20 to 30. So 7 plus 10, 17 students. Like that we need to give probability. So 17 divided by 90. So here probability a student attained less than 20% is 7. Less than 30% means 7 plus 10, 17. So here only 20%, so 77 divided by 90. Now number of students obtained marks 60 or above, 23. So a student obtained marks 60 or above, 23. So 23 divided by 90. Thank you, students.